what we're about today is real-time monitoring with a product we call Database Watcher. It's an Azure forward monitoring solution for your PaaS services. This is a little bit about me. You don't need to know about me. Find me on LinkedIn, find me in the mountains. Most importantly, here I was talking about you can find how to set up Database Watcher, set up your SQL connectors, all the different things that people run into issues we have there on the channel already. So
What
at the rep
channel is it, Dan?
Hmm?
What channel is it? So it's Tales from the Field.
Yes.
It's a YouTube channel that you run with several of your colleagues from Microsoft.
Yes.
We have a whole bunch of videos up there on SQL items, but also on Microsoft Fabric. We have monthly live streams with Fabric Product Group.
This is Brad. I also have Thomas Larock here. I brought both of them in as surprises because Tom is an MCM. Many of you may know that. He also does a lot of performance and tuning. He's instrumental in the community. He's also an MVP. Bradley Ball, he does deep dives in performance tuning. He does a lot of different things to help you make your system run better. So I wanted him to come in here and bring us some commentary around some of what's happening here. All right. So what are we going to talk about today? DBAs, devs, and operation teams are awesome, right? I love all of y'all, right? And each of us needs a way to be able to monitor our systems. And how do we do that? Well, one of the things we're going to talk about that you can do that with is Database Watcher. A lot of great products out there to do this monitoring. As a matter of fact, SolarWinds is out there. SolarWinds is another great product to monitor your different SQL Server environments. What we're going to talk about today is an Azure forward one that monitors your PaaS systems. We'll look a little bit at cost and feedback, and we'll do some Q&A at the end. We have two types of DBAs. And we've all played this role. And by the way, there's about 19 slides at the beginning, and then there's going to be about 45 to 50 minutes plus of demos of Database Watcher to show how this actually brings value into your environment. We've all been here. We've been reactive DBAs. We've been proactive DBAs. The reactive DBA probably has been the majority of my career, right? So how many folks here feel like as a DBA or somebody who's in operations, most of their life is spent being reactive because we don't have the tooling and we don't have the capabilities within our environment to look at things after they happen. So great. We've got the proactive DBAs. I've tried to become more proactive as I get older in life because one, I value my weekends. I value my time with my family. I value that, right? And it makes for a happier life for me. So why do I bring this up? One way we can be proactive is by monitoring our environments and having a historical or a point in time place we can go and look and see what's happening within our environments. Anything there, Brad, from a reactive or proactive perspective?
No, I think that's absolutely right. As we look at the monitoring software as well, many of you are familiar with this. How many people already have monitoring software in a production environment? Okay, majority of the room. So you're familiar with it. One of the key things when we go, why would you want to use this? Well, first off, if you're in Azure, if you're using Azure SQL Database, if you're using Azure SQL Managed Instance, this is built by the product team. Built by the product team that actually builds the product. And so if you think about it, there's no monitoring platform like this that's been built that uses our technology, our telemetry. And this is literally what we would use if we were looking at our internal systems to go, how do we make this faster? And so that proactive nature that you're already used to, take that and then make it come from the product group. And there's some things that we do on here that we track that I haven't even seen on third-party softwares before. And so it's a really, really cool feature for this. Not replacing everything, right? We're not covering Postgres. We're not covering MySQL. We're talking specifically about SQL when we talk about this product.
Awesome. I love it. What do we have? We have a way to be proactive now. We have Database Watcher. Database Watcher monitors, to Brad's point, Azure SQL Database and managed instance. What does that mean? So with Azure SQL Database, you have Azure SQL DB and you have Hyperscale. Database Watcher monitors all three of those. Not only does it monitor the primaries, if you have geo replicas of those or failover groups, it will monitor those as well for you. And we also monitor SQL managed instance, not only will it monitor your primary node, but it'll monitor your secondary node as well. It's a Microsoft managed data collection agent. That is like a marketing term if I've ever seen one. What does that mean? That means we spin up a server for you and we don't charge you for that. And it's going to collect the information for us. Now, there are some fees that you will pay. We'll look at that in a little bit, but this service is completely free to you. And you can monitor right now up to 50 different databases, they upped that to 100. That will grow in the future. There's about 10 to 20 data sets that we derive from over 70 system views. So it's going to be all those views that you're used, all those DMVs that you're used to pulling. If you were in our session on Monday, you would see some of those system views, the operational stats in that we talked about to pull your CPU, your IOPS, your throughput. We gather from those DMVs. This is one of my favorite ones. You can use Entra or secret or Key Vault secrets. Now, my recommendation is never to use SQL logins unless you absolutely have to. Use managed identities to be able to connect to your SQL or your Elastic Pool or your managed instance endpoints. And it allows for a level of security that is recommended.
When Dan says managed identity, does everybody who doesn't know what a managed identity is? Raise your hand if you want an explanation. Okay. So what is a managed identity? So managed identity, when you provision a service within Microsoft Azure, Azure SQL database and Azure managed instance, the name that you give it is an identity with an intra ID. And what you can use is you can give permissions to that name, to that service, so that way it can execute under those credentials. And so you could say, take data set and you could say, I'm going to give access to be able to read this data and I'm going to authenticate to a data pipeline using my managed identity. And so that way I can take that service and I can give it permissions. I can make it very granular. I can make it, DB data reader doesn't have to be able to write, or if I want it to write, it could have DB data writer, and I can manage that identity. And it's more secure than a service principal because there's no SAS token behind it, and you're using the identity specifically of that service. And so it's service to service communication. So when Dan says use your managed identity, you can take the managed identity of Database Watcher, you can add it to your Azure SQL database or your Azure SQL managed instance, give it the permissions it needs to be able to read those views. And it's a very low level of permission, which is always the best practice. So that way it can pull in data from these DMVs. And so when we look at this, there's a secure method. There's a lot of places where sometimes a product comes out and then the feature you're requesting is the security. I will give the team credit. The security was built into this, the ability to connect to private endpoints, the ability to use service principals if you want to, but also the capability to connect using managed identities.
We have a single pane of glass with detailed visualizations. I'm going to finger quote there because I'm going to show you something that we may need to do, that you may need to step away from this single pane of glass, but the juice is worth the squeeze, and we'll take a look at that. It uses Azure Data Explorer. Calm down, Brad. I know you get really excited when I say ADX. Microsoft, basically all of our monitoring behind the scenes, when people ask, how are you doing this? They're doing it with an event house. They're doing it with real-time intelligence. They decided they made a conscious effort to store the data, to stream the data into an Azure Data Explorer, or you could use Fabric Real-Time Intelligence. I leave the analytics there because we started as real-time analytics, and it's kind of a funny joke because some of the screens when you're setting this up still call out real-time in analytics. And what this is if you're deployed in Fabric, how many folks are using Fabric today? Okay, good. So in most cases, you folks would be using an Azure Data Explorer cluster, but I recommend looking at Fabric to store this data in because it really provides you a level to democratize your data in a way that we've never seen before. And it's super fast. So definitely look at using real-time intelligence to store your data. So that's your data store. We also have private links if you're connecting to your SQL endpoints. A lot of companies require a private link to be instantiated or deployed to be able to connect to it. We connect to Managed Instance, your Key Vault, and your Azure SQL DBs through a private endpoint if you want to. You don't have to, but it's highly recommended. Real quick diagram of what Azure Database Watcher looks like. Over there on the left, you have where your identity is, where your data store is. Your data store is that Azure Data Explorer or your Fabric Real-Time Intelligence. The targets over here, you can see we have Elastic Pools, Managed Instance, Azure SQL Databases. Those will sit inside your Azure SQL estate. These all need to be within the same tenant for now, but they can live in multiple subscriptions. We have our data store down here where you can use Fabric, Azure Data Explorer, and then you have your dashboards. Something really that I didn't call out on the previous slide, but if you're kicking the tires and you're showing this to management, you can spin up a free Azure Data Explorer. You get that for 1 year. That will make the cost of Database Watcher free for 1 year. Now, there's limitations to the Azure Data Explorer cluster, the free one. I think it's 100 gig limit and stuff like that. But for kicking the tires and monitoring 1 or 2 systems, it's plenty of space. I do it all the time. Network and data access. We talked about this a little bit. Data access, we provide access of least privileges. Here you can see the level of access that we need for Managed Instance, and down below what we need for Azure SQL Database. That is access to least privilege, folks. That's just looking for view capabilities. If you're deploying a monitoring system and it's asking for anything like elevated privileges like sysadmin, question it. And that's a soapbox I'm going to stand on. Question it. We don't ask for that. We say basically we need view or select. I saw you turn on the mic.
I was gonna say, do you want me to tell the story real quick of when we were at Publix? And the
You, yeah, tell the story.
Okay, so when we were at Publix, there was literally a monitoring system that we were having come in, and they were supposed to monitor everything, network and application database. And we had all these different teams, many separations of processes. I did not control the passwords. If I needed a password, another team would set it. We would call them, they would give it to us. And if it ever got changed, they were the ones who would control it and communicate it with us. And so I'm working with the install team so we can get this in for a POC, and they say to me, "Here's the username and the password for these." And I go, "Yeah, that's not gonna fly. We've got a team that'll set the password. They'll give it to us." And they say to me, "You can't change the password." My spidey senses go off. I go, "What do you mean we can't change the password? That would suggest that you've got this hard coded in your application and you're asking for SA access on our databases and domain controller access and all these other high level accesses." And they said, "Well, that's what we do with everybody." And I said, "Yeah, that's not going to work." So, of course, I tell my bosses, they aren't happy about it. We've got this big conference room. There's tons of us in the room. They get on their VPs, like, "Who's this loudmouth DBA that's saying we've got problems with this?" And I go, "Yeah, hi, that's me. I'm the loudmouth DBA." I said, "Real quick," I said, "before we get going with this, you had American Express talk to us to tell us what a great product this is, why we should use it." I said, "I'm an American Express cardholder, and I now realize that because this is hard coded, I'm not a nefarious person, but I have the SA password to one of their prod instances that is tracking all of their information for their entire network. Now, as a card member, do I call the number on the back to let them know this? Or can you give me the email address of the person you had talk to us and I can just email them directly?" Naturally, the phone goes quiet. And it goes quiet for long enough that my boss's boss looks at me like, "Good job, kid." And he goes, "Hey, my pain in the neck DBA asked you a question. Are you guys going to answer us?" And they come off mute to go, "Just 1 second." And amazing thing, they come back on and they go, "Yeah, we're going to fix this. Don't worry." And we got an email the next day that there's a new feature making this more secure than ever before, where you can change these passwords. So
Yeah.
yeah, if it's not a bug, it's a feature, right? Until it's a bug.
Network connectivity, once again, want to emphasize and drive home private endpoints and make sure that those are approved once you deploy them. SQL permissions, we went over that. Access of least privilege here. Choosing your data store, RDX versus RTI. We won't go deep into this because bigger than a breadbox, smaller than a 747. Why I would choose Azure Data Explorer? If I need the free version available for evaluation, great reason to choose ADX because we can't get that in real time intelligence. And now that I think about that, you kind of can if you use free trial of Fabric. Um, Out of the box alerting. We're going to look at this heavily. It's the either going to be the first demo or the second demo, depending upon what time my watch says after we pop out of these slides, and it's a PaaS service. So this is something that is going to be um, Azure inside your Azure billing. So it's a PaaS service you spin up. Real-time intelligence has all the benefits of Fabric. Now you can throw Power BI reports on that, and Brad and I showed that last year. We don't have that this year, which now to my chagrin is a disappointment that we didn't add that. But next time, look for a video on that. You want to create custom alerts. I'm going to show you what those look like and how you can do that. And there's actually a really easy way to get some of these alerts set up and configured. And it's a SaaS solution. So basically in Fabric, and I'm going to let Brad touch on some of this here in a second if he would like as well. In Fabric, it's consumption units. So you're paying for the consumption of the product. And as you're paying for the product, when you select real-time intelligence or Azure Data Explorer as your data store, you're going to go in and you're going to set up the number of days retention you want. You're also going to pay for storage on the SaaS. So you're going to pay for how much you consume it and how much storage. Over on your PaaS, you're paying CPU, storage, compute, all of that as like you would normally with an Azure SQL DB.
This is so fast. When me and Tom and Dan taught this as a pre-con last year, I would literally start issues on the system and we would see it come through. This typically has about a 3 millisecond latency. And so there's been some previous monitoring solutions we've had in Azure where it takes maybe 5, 10, 15 minutes to be able to update. This is not the case. This is so good that if a production issue is happening, you can troubleshoot it and use this product right now, right away to see what is going on the system.
Dataset categories, not going to drain this slide. This slide has been uploaded to our things, but we collect performance, storage, configuration, monitoring, and replication. Why I'm not going to drain this slide is because we are going to look at this in a live use case here in a bit. We're going to walk through each of these, and you're going to see pretty much every one of those metrics appear during the demo. Database Watcher and KQL. Why is Kusto so good at this? It's highly scalable. It's made for monitoring and reporting on uh, data sequences. It's optimized for, sorry, it's optimized for time series data. I don't know where that word came from. It's the same. And it's a short learning curve for SQL professionals. Do you have a video on this or the best kept secret? I know you did it at SQL Bits, but explain to them why it's such a short learning curve for us SQL professionals.
This is the most AWS service Microsoft has ever made in that we created this. We literally track the telemetry. There's this amazing command center up in Redmond. And if you go in there, it's like 4 stories, wall to wall screens. And we are tracking the health service of every Azure service in every data center across the world. And it is color coded. And we also have this counter of the trillion of denial of service attacks per second that are occurring that we are mitigating. And it is just phenomenal to watch. And I was talking with people who were on the floor. I said, "What product is this? What are we using to track this?" And they said Azure Data Explorer or Cousteau. That was its first internal name. Microsoft doesn't love something if they don't rename it. And I think we're on our fourth or fifth name for this product. But we built it, we're using it, we're literally running Microsoft off of it. And somebody goes, "Hey, this is a great product. We should offer this to customers." And so when you look at real-time intelligence, when I was doing this with Patrick, one of the demos we did is Patrick queried a 3 petabyte data set to be able to find out all the telemetry from Power BI, who was getting the most errors, who was the most frustrated user, and all of Power BI. It was Adam. No, I'm just kidding. But whoever it was, we went through that 3 petabyte data set. We aggregated it. We had those totals back, not in minutes, not even in seconds, in milliseconds. And so this is incredibly powerful, incredibly fast, and it is just wonderful. So when it comes to performance insights, low latency data, being able to put that data in place for us to be able to monitor off of, you cannot have a better tool than this. It's absolutely amazing.
It's the best backend. And look, we're SQL Server folks, right? Brad and I are SQL Server people, and we're touting about this. You know, when SQL Server people are touting about something else, it's got to be good. So on the left here, go ahead. Yeah.
Well, but one thing I would say, if you use Fabric, you can actually write T-SQL against KQL. If you use Data Explorer, they have not put that functionality in place yet, but you can literally say explain at the top of a SQL statement and it will translate it to KQL text for you to turn around and execute.
Yeah, I put this slide as a Brad slide because I put this in here just for him because he taught me this, right? A couple of years ago. He's like, "Yeah, write your T-SQL in this." But what you can see is all of this is required for your time series data, and it's reduced to this subset of KQL statements over here. So yes, we are asking you to embrace a new language, but it's very similar to how we use T-SQL. However, it's order of operation. Like you can see how it's querying the data here. It's how I want to return the data, and that's why it's easy for us to consume and learn. Now, when you start getting into the complex functions, it starts getting fun, and yeah. So
Powerful language, but for what you need to do, I mean, it's gonna be fantastic, and keep in mind, copilots, they know how to translate SQL to KQL, so if you need any help with that, I would write this in this way in SQL, translate it to KQL for me. Every copilot that we train can do that because this is a language we use very heavily, our copilots are trained on.
All right. So over here on the screen, I have Database Watcher considered a past service. Once again, we manage it for you. So if you came in here and you searched on Database Watchers, it would pull up. Now I've got two deployed here. I only use one for my monitoring. I've got two deployed here so I can show you something very specific about Database Watcher. Now I want to ask the question real quick. I usually go the first 5 to 7 minutes showing configuration. I have 3 videos on our channel. I would much rather show you the meat and potatoes of this and the database dashboards that you can create and how to create alerts. And we can skip that now and then get into the actual use case. So I wanted to make sure the folks were okay with skipping the configuration part.
Yeah, meat and potatoes, raise your hand.
Meat and potatoes,
There we go, let's go.
configuration. Meat and potatoes, boo! I love it. All right, so good. So we will go right into the meat and potatoes. So the first thing I want to cover, and we talked about a single pane of glass, a real-time dashboard, right? So the first thing I want to show is on that dashboard, we can create alerts. Well, there's two things I called out in that slide. If you're using Fabric, you can't create alerts. But Dan, you're saying you can create alerts. So let's go into this database watcher real quick here, this Live 361 I've deployed. Now there's nothing being monitored here, but what I wanted to show you is if we go down here, oops, sorry, first thing I want to go here and reduce this, and I'm going to go to alert templates. I want to pull this up. You can see here now on the top, it's saying creating alerts is not supported inside a Fabric real-time intelligence database. So that's how I know I'm using real-time intelligence as my data store here. So, but what I wanted to show is that you're going to get this error message here if you try and do this. The second error message we'll cover here in a second because I'm going to go back to my database watchers and I'm going to go to my Live 361. Over here, I'm going to create on alert templates. Now, you can see that the alert is gone, right? We don't have all that red messaging up here at the top. The first thing we need to do to make this work is we need to set up a manage alert rule identity. Now, it's easy enough to configure what you're going to do, and you may not have access to this, is you're going to create a Microsoft 365 account, and it's going to be a system user and you'll assign it here within your environment. And I guess I need to do a video on that as well. So that's good. So first thing you'll do is you'll get this alert. It's easy enough to do.
And that user is the user that sends the alerts, correct, Dan?
That is the user that sends the alerts. Yes. So with that alert set, you have out of the box with the database watcher, you have your administrative alert. Now, this administrative alert is only going to work on our managed instance. And if you're not familiar with Azure SQL DB today or managed instance today, which is our first party or our first class PaaS services for SQL Server, you'll know that Azure SQL DB doesn't allow you to have SQL Server agents. Managed Instance does. And down here on the bottom, you'll see that the alert has a Azure SQL Managed Instance or a SQL Managed Instance there. That identifies what the alert is for. Now, why is that important? And we'll look at this when I drop over to show you the Fabric version of this. When a KQL database is spun up and we deploy Database Monitor to watch a SQL Server, an Azure SQL DB, it's going to create an Azure SQL DB table. If we create an Elastic Pool, it's going to create an Elastic Pool table, and so on and so forth for each of the different services we monitor. Now, when we monitor that, you can query across all three of them, but they found because there's different items we monitor, it's best to have those in the three tables. You'll go to availability. This is really important if you're looking for alerting on if you have geo replicas, if you're doing failed connectivity probes, there on the screen. That's interesting. So when we look at a Azure SQL DB or a managed instance to see if it's up and running, we call it a probe. It's out there probing to see if it's running. If you want to know if you want to get alerted on if your Azure SQL DB is up or down or your managed instance is up or down, you'll set up these alerts. Do not do like I did. Do as I say. Um, I shut down my services at night and I put failed probes on this. And I also have serverless DBs that I shut down. I woke up to thousands of emails the next morning. So just be aware that if you shut down your services, make sure you don't deploy a failed probe against that. You have resource usage. This is where, from a DBA perspective, this is really where you're going to look. These next two tabs, high data IO utilization. That's one of my favorite ones. Low data storage. I like using that one a lot, even though a PaaS service and we can easily scale that disk up. I still like knowing because if I scale my managed instance up to 2 TB, I can save a little bit each month. And I think that's good, being a good steward of your data these days. So you can say, hey, I'm getting close to my managed instance storage limit. Send me alert. I can call my boss and say, hey, I need to spin this up by another 500 gig or so. High CPU utilization, high worker utilization, so on and so forth, out of memory events, right? Just the things that we like to be alerted on. So you have that, and then workload patterns. We won't drain this, but my favorite one here is the ones on the top: blocked requests and then deadlock spikes. These are some of the items I see more frequently. Tom is looking at the screen, so he may have a question, but these are some of the ones that I look at setting up when I've deployed to an Azure Data Explorer cluster out of the box. Did you have something to say, Tom, or a question?
My curiosity was if there was a default for the blocks before that says you're going to define duration.
Yes.
Is that so? That rule be for multiple instances being monitored. So in other words, when I pick a specific instance, where I will, or does it by default puts it everything that's already gosh.
Good question. So the question is how configurable is this? Can I monitor it at an instance level or at a database level? And the answer to that is yes. You can monitor it at an instance level or a database level. It's configurable enough that you could do that. Did that cover what you were looking for there? Sure.
Close. You have this configured against just one SQL managed instance. So
Correct.
if it was configured against 5,
Yep.
and I create this alert rule by default, does that rule go against all 5?
That's great. So the question is, if I have one SQL managed instance set up today, and let's say I have 5 in the future, will this alert monitor 1 or 5? It will monitor 1 to n. It will monitor them all. So I can monitor one managed instance with this, or I can monitor all my managed instances with this.
By the case where I only want that rule against 2 of those instances and not all 5,
Correct.
do I have to reconfigure things and split it out manually, or can I just say this rule against these endpoints?
So you can repeat the question is can I configure this again? Do I have to reconfigure, or can I configure just against these instances? yes, you may need to reconfigure if you've said monitor all these. And yes, you would need to reconfigure if you only want to monitor a couple of them. So yes, there is some reconfiguration there.
But you could have a subset of them. I think that's what Tom was getting at. You could have 2 out of the 5 that you wanna monitor if the other 3 are, like, dev test instances and you wanna pause them. You don't have to monitor all of them. Correct. Yes.
Yes. So that is Database Watcher out of the box. Now, if I deploy to a Fabric RTI data store, what we need to do for alerting is we need to set up our dashboards. Now, I'm over here inside my real-time intelligence workspace, and I've already got alerts set up, or not alerts, dashboards set up. So what it's going to do is it's going to pull alerts. Now, you remember a little bit earlier, I called out that we have individual tables that gather the metrics from the managed instance or the Azure SQL DB that we're monitoring. And I've set up multiple pages here. So you can have within your database watcher dashboard, you can have multiple pages. In my first page, I'm monitoring my managed instance, and we'll get into the actual database watcher dashboard here in a second, but I wanted to cover the dashboards first and how you can customize this, because some folks get overwhelmed with the dashboard because we have so much. If you want to set something up specific for your environment, you can come over here and set up your own dashboards. Here, I've picked some of the things that I'm usually most interested in, or clients most often ask me about when I'm monitoring, and that's read throughput, write throughput, CPU percentage on my managed instance, and CPU use. Now you can see here, to Tom's point, inside the alert, we may have to do some reconfigurations. Here, I'm using basically a query that is pulling in my managed instances. So I could drive this through a table if I wanted to and make that more easily configurable in the dashboard. So you could say, okay, these are the ones I want to monitor, put an N or a Y there, and start your monitoring. Now, what also I find very cool about this is if I went in here and I edited, I could come down here and you can see the visual formatting. And right here, you can set formatting. So I can give color coding. So go above, when I go above 60%, I make this a yellow. Now I could put a red there if I go above 100%. So you have this intuitive dashboarding that you can build out and show color coding. However, Tom last year came to me and he's like, Dan, I don't have time to go into a dashboard and look at it every day. So what can I do there? So I'm going to go ahead and I'm going to close this down. I'm going to go back to my database watcher, discard changes. And right here, you can see we have a little lightning bolt. This lightning bolt is basically our activator, and you can set an alert. And what this alert is going to do is you can come in here and set the minutes. Now, for the alerting, the minimum amount of time you can choose is 5 minutes. So you could say, okay, I want to pull this alert and go look at my KQL table every 5 minutes. And I want to pull that data, and you can group it, and you can say, like, I chose top CPU, and then you could have a condition. When your condition, and I like to use a condition, for example, is greater than or equal to, like if I wanted to alert on that 60% rule, I have it as a yellow color code. So I want to get a warning. I can send an alert after it hits 60%. The coolest part is you can send it to an email, a message in Teams, which is pretty useful, or you can run a Fabric item. So you could run, if you have really smart people on your team, you could run a custom Fabric item to alert or log it to a alerting system or your ITSM system to get alerts from that. So right there is how I wanted to show where the value of Database Watcher comes from a democratization standpoint, and how you could, one, set up custom alerts through dashboards and Fabric, or use the out of the box alerts in the Azure Data Explorer. Now, So that's that. And you can see I'm using my CPU and everything here over on my server. Let's switch back over though to my database watcher. And this is going to be what we're going to walk through now is we're going to walk through a semi live use case that I went through. The names have been obfuscated to protect the innocent. I'm using TPCC to put a stressor against my environment to get as close to what I had at a customer event where we were having an issue with their managed instance and we couldn't figure it out. They had spent days figuring it out. And the story was this, is we deployed to a managed instance on a Friday. We made the full cutover. Everything was running great. We had 5, 10 users working against it. The initial kick the tires test went great. Saturday and Sunday went by. Apparently they didn't call me. More and more users started using the system. Sunday evening hit. A lot of people come in. Managers come in prepping for their Monday morning meetings. This was a shipping company of one way or another, and they sent out a lot of big semis, and they were having a lot of performance issues. They reached out. I was speaking with them. They're like, we're having all these performance issues. We looked at all these different things, and I started digging in with him, and we couldn't really figure out what the issue was. So I asked them, I was like, are you able to deploy a preview feature? They're like, absolutely, we can deploy a preview feature. So I said, let's deploy Database Watcher. And the story you're about here, dong dong, is us walking through Database Watcher and solving the mystery of what their performance issue was. So let's go in here and close this down. And this is the dashboard. This is the overall dashboard. When you come into Database Watcher, what you're going to see. You're going to see the Azure SQL databases that you're monitoring, your Elastic pools that you're monitoring, and your Azure SQL managed instance. Now you can see over here that 2 out of the 3 are not collecting. That's because I know one of my Azure SQL databases is basically set to pause, so it can't collect. But what I wanted to show is if you had some environments being monitored here, you'd get an alert as to the probes that are failing. Now, the next question I normally get there from, okay, this probe is failing. Why is it failing? We don't necessarily, I've provided the feedback to the team. We don't necessarily give you an easy way to do that, but you can write a KQL statement and say, look for failed probes. If you're interested in getting that KQL statement, please email me. I have it written down, but you can go out and query your data store to find the failed probes. And I have managed instances monitor here. Now, what I want to show here is that I'm monitoring my Data MI, East US2, and my Data Free MI. The East US2 P1 is going to simulate the environment I had at my customer. They like this chart, the heat map. I personally like instances. It's easier for me to read because it gives me some information there on the screen in a little bit, from my perspective, easier to read format. You can see that I have my free MI, my free managed instance up and running, and I have my East US up and running. Let's drill into the East US first. Well, let's drill into that one, period. So the first screen you get to is your performance screen. This is really important. This is the one I usually start with. And I'll share some of the things I could have probably done better as I go through this to solve the issue, because I could have started in one place and probably solved it in the less amount of time that it took us to solve this. And I'll tell you how long it took us to actually solve this problem once we installed Database Watcher against the target that was having the issue. You can see here that we had performance issues. Why I wanted to show this and why I started here is we looked at the workers and then we looked at the CPU. When we looked at the workers, the CPU and log write, it was a similar situation here. Now they were in the 50 to 60% range up here, but I wasn't concerned about that. They had plenty of vCores still available to operate. So we looked at that and it's like, we don't have a CPU or a core issue. We scrolled down a little bit more, and what do we all love as DBAs? One of the things we look at first, outside of looking at what's going on with the cores and the performance of our database, is our weight stats. So we have our cumulative weight stats, and let me zoom in a little bit more there. We have our cumulative weight stats, we have our average weight stats, we have our average signals, and we have our weighting tasks. I asked them to scroll in and we looked at our average waiting test. Now, once again, this is similar, but not exactly to what they saw, but we were seeing a lot of Page IO latch inside, and we were seeing a lot of lock mutual share and exclusives. So essentially, we were getting a lot of reads from disk. And I was like, why are we reading from disk so much? Was this similar to what we had on premises? And they're like, no, pretty much everything loaded into memory at one point or another. And I'm like, okay, so we're reading from Page IO. Not great, not horrible. Maybe that's expected. We were getting a lot of latches. I'm going, okay. Um, so this really didn't yield the results that I was looking for. Now it gave me some places to look. One of the places I probably should have looked at first, based off of the Page IO latch, was storage. I'll share the secret up front. What I did wrong is I checked storage last, and we'll look at that here in a bit. But I checked storage last. When if I had looked at this correctly, I probably should have looked at that first. But what I want to show is it gives us the detail. We also have memory consumption here. You could see the different memory usages. We didn't have any issues with our total target memory, our memory. Everything was looking good there. So the next thing we did is I asked them, okay, let's go up here to our tasks and let's just look at properties, right? I didn't necessarily believe that they spun up the proper number of cores or that they were using the proper managed instance or something like that. Trust but verify. So I looked at the properties, just what I wanted to show here. So we don't have to do this, drain this, but inside the properties, you can show very important things. You can show what version your managed instance is on, how much storage you have, the different properties. We went over cost threshold for parallelism. We went over those different items within our class the other day. If you're a DBA, you know that you look at these things. When we looked at this, the time zone, I wanted to make sure. So you can see here that it has all this information about it. I also looked at the memory and the cores just to make sure that we were telling the true story. Now they have more cores than this, but it showed that with the 16 cores, they were getting the proper amount of memory allocated to their managed instance so they'd be able to run it. So we said, okay, nothing to see there. Move along. These aren't the droids you're looking for. The next thing we went to were their SQL agents, and we wanted to look at. Now, I don't have any SQL agents here, but we wanted to look at when their SQL agents were running. Developer had access to run SQL agents on site on the managed instance, and he had T-SQL in there that would update the database and do certain cleansing things through the SQL agent job. We rectified that in the future, but that's where they used to update their data and then cleanse it, um, rather than through an application. During the time frame where we're having our outage or the performance issues, what this showed is that this was not running anytime within that time frame. So we didn't see any issues with the database SQL agents. And once again, I chose the storage last, which I wish I had chosen first, but or second. But the next thing we went to is we went to activity. Now, this is really cool. As a DBA, I want to see what's happening on my box. And right now, you can see on my box that we have a lot of blocking. We have a lot of updates going on, some rollback transactions, some inserts. This is really cool, right? So we can see exactly in real time what's taking place on our box. And you can see all the issues, all my blocker processes. What a monitoring tool is intended to do is to show us what's happening real time. This is all real time too. I can come up here, I can filter by my block processes. If this loads, it's going to show the block processes. You can derive the block processor tree from this. We weren't necessarily getting a lot of block processes, but processes were being blocked, but we didn't see anything there that was the issue. So we went through, we looked at everything that was going on in the box. The next thing I said, okay, we looked at activity. We know things are bad. I can see that now. I know we looked at queries. They sent me information. They said, these aren't running quickly. They're not running as there is. And here was the proof in the pudding. It was something very visible to us. So we went over to sessions. Um, Sessions for me is really important because if you're ever been a DBA, you know that occasionally an application will write and it'll go awry. And they'll, rather than running a stored procedure that should run 10 times, it's running 30,000 times in a short time frame. So we went over to our sessions and we looked through the different items here. And we looked at the logins. We looked at where all of the logins, which host they were coming from to make sure we didn't have skew across the different hosts that were coming in and reporting off of this. We looked at the program to see what program it was, and sure enough, it was the program that was sending out the trucks in the morning that was having the issues executing those reports coming back. So we're like, okay, we know we're on the right track. We know we're in the right church, maybe the wrong pew still. And we went to the database. And sure enough, out of the 4 databases on that managed instance, all connections were going to it. So we were narrowing it down further. So using the tools, we could see that, we weren't exceeding our number of user sessions because each SKU is going to have a max number of sessions you have. This reported that for us. This gave us that information. So right there, we were able to say, okay, we know that we have sessions going on within this environment. We know we have X number of sessions. It's no more or no less than what we had on premises. So that all still lines up correctly. So we don't have anything running away with itself. I went to top queries. I was like, okay, let's go to top queries. Top queries is really cool. Once again, they like tiles. I like grid. So inside their environment, you could see that they had the top queries. Now, here's my TPC database, and you can see that they are my top queries over here. And inside the last hour or two, I've run about 797,000 transactions within the last half an hour or so, hour against this database. This is what it looked like inside their environment. There was a store procedure or store procedures. They had 4 of them that were very near the top. And we're like, wow, okay. And they were in the millions. So it was so we were like, maybe we have an issue with the store procedure that we're running. Cool. We found it. We found it. We got all excited. So we went in and we clicked on the top one. And as you click on items within Database Watcher, it won't look like it did anything, but it lights up information down below. So it pulled up this query SQL text that it was going, still has the buffer issue. If you used to pulling the query text from the buffer, because there's a Mexican store in there, it still stores this. It's pulling this from Query Store. And then you could see how many writes, how much CPU time it had, what the actual plan hash was if you wanted to go and look at it, the different parts of the plan and how it was using that. We were interested in this, but the thing we were mostly interested in was the query plan. So if I go here, I'm in the wrong queue, right, church? Wrong queue. If I go here and I click on, there we go. If I click on that bar here for our plan hash, and I apologize, let me zoom in on that. If I click on the bar for this particular plan hash, that meaningful name there, um, it will open up this little dialog box right down here, download query plan. So what we did is we downloaded our query plan for the 4 queries that we saw at the top there, the ones that were consuming most of the resources. We downloaded those. We opened them in our favorite debugging tool, SQL Century Plan Explorer, and not SSMS, because they were really large query plans. And SQL, if folks aren't using SQL Server Query Plan Explorer, is a great tool, great utility that you can utilize. It's completely free, and it makes it really easy to dive deep into the query plans. So we started digging into the query plans. Everything looked good. We pulled the ones from on premises that we had pre-migration, which, by the way, pull your query plans from your original environment so that you have a baseline to look at. And we looked at them. Everything was perfect. Everything was exactly the same. So where we were jumping for joy, now we were kind of sad faced again. So we're about 50 minutes into this adventure, right? Debugging things. And it had been a couple days, but it had been about 50 minutes since we put Database Watcher on there to dig into this. So the next thing we wanted to do, I was like, okay, so it's not our performance CPU or anything. Our weight stats kind of look like our box on premises. We don't have anything going in properties. There was nothing wrong there. SQL agent didn't show anything. The SQL agent, the weird queries that the individual was running, and it was running outside of the schedule. We looked at our sessions, all that looked right. We had no more or less sessions on that. So I was like, let's just look at backups. So we looked at backups here. Backups will run if you're not using any of our PaaS services today. It's important to point out backups on PaaS services run a full backup once a week, differentials, más o menos every 12 to 24 hours, and a log backup about every 15 minutes. So when it's running those particular backups, sometimes there can be impact on your environment, right? Well, we were looking at it, very small log backups. Also, just to point out, a lot of security teams now have asked to have Database Watcher installed because it easily maintains how many backups you have and that you are backing up your PaaS environment. Because on premises, on a VM, easy peasy, you know exactly when they were. But in PaaS, it wasn't originally easy to track. Sure. So it wasn't that. So it wasn't the backup. So I was like, okay. And
Could you click on log real quick just so we could see the details? Just so that way, yeah, I mean, simple, but that's what it looks like because that's one of the things they want to know. How long did it take? What's the average minimum statistics and what the backup interval and when were they taken?
good call out. I thought I clicked on that. I apologize. I was talking about it and then there was nothing there to see. Magic. All right. So that should there. So the last tab, the only thing I haven't shown you all is storage. And knowing what I saw up front with the page IO latch, the weights, the blocking, I didn't ask the right questions. And with an Azure SQL managed instance, you get IOPS based off of in general purpose, based off of your disk size. And I didn't ask the right questions. Now we have general purpose that I have a video on our channel that talks about that. But with general purpose, you can hit this nice little slider and get your IOPS. But with the original general purpose, and it still stands true today without next gen general purpose, um, your performance of your database is going to be based off of the disk size that you lay down in your environment. And I'll get to why, if I had asked that question up front, it probably would have been an easier solve. But how did I identify what was going on there? And it was all right in front of me, right? I had the database information, I had all that, but I didn't put one and one together. So we looked at the storage, and the storage is really cool. So within the storage, you get instant consumption, you get all this great stuff. Down below, when I look at my instance, you get your IOPS and you get your write IOPS. And this is really important with any of our PaaS services. Based off of your vCPUs and the amount of disk you have, you get IOPS, right? So we were seeing the IOPS, and I already noticed based off of their server size, they were hitting a limit. And you can see here within my environment, I'm hitting a limit. So we went to throughput, and I like throughput versus IOPS. This told an easier story for me. So I went in and I was looking at their different spikes, and they looked similar. They were a little different. Their line was a lot flatter than mine. I mean, it was pegged. It was all the way at the top. And what I noticed was their write throughput was maxing out. It was just a flat line. It was 500 meg per second, where it was just maxing out and wouldn't go above it. Would go below it, but it wouldn't go above it. What that told me, and I pulled that up here. So I asked Copilot, our friend, I said, okay, we didn't have this back in the day. I went to the SKU, but based off of my environment, this is the max I should expect with 4 cores, 20 gig of database size, max IOPS, I should get about this and about 20 megs on the file system there is what we're seeing within my database watcher. When I pulled up our old school here, our stats, this is a blog post and I need to re-upload the slide with this in the link. But what they had is when they deployed their database file size was only about 50 gig. So the maximum amount they could get was 100 meg per second throughput. Well, we were maxing that out. And I apologize. It was 100 meg they were getting, not 500. So we were maxing it out. So what did we do? Within an hour, we identified this. Could have probably been less time if I was smarter, but it's just storage first. But hey, I went through the normal procedures I did as a DBA to try and figure it out. Well, we figured out we had two options. We could grow the disk size to the 1 terabyte to get what they were equal to within their environment, but their database was only, 20, 50 gigs. So that was a lot of wasted space on the managed instance. So this company had a very strong appetite to use next gen general purpose. We turned on next gen general purpose, and all of a sudden, this little slider here began to get the little peaks and valleys, and that solved their process. So from a 2-day exercise to an hour exercise with Database Watcher, we were easily able to identify that we had a storage issue, not a performance issue, not a query issue, not a migration issue. We didn't have enough resources for our retail system to be able to process the data correctly. So we were able to dive in through this use case through that. That is the demos on Database Watcher. Did anybody have any questions around that? Because I said lots of things.
Dan, just to reiterate, the solution to the problem that you had was the data file was too small. So in general purpose, what we had said, not next gen, which went GA this week, has a slider where you can increase the IOPS on it. And the maximum number of IOPS you can get on that are still related to CPU core. For regular general purpose, if you're using that today, if your data size, your data file size or your log file size, if they are less than 129 gigabytes, they're going to end up with only 100 megs that they can have for a throughput write ratio for megabytes,
Right.
but 500 total IOPS. And in order to be able to get to the next level, you have to make it up to 130. But those go in segments. And so they go up to 4 terabytes in size where you can get the maximum file size. We do have a video that we show how to be able to get better performance on the traditional general purpose by showing those. We do it against the TCP or HammerDB and the TPCC workload. And we basically go from, single digit thousands up to hundreds of thousands of IOPS per second.
Hundreds of thousands. And it's with the next gen general purpose, you get by far a lot more IOPS than you will with general purpose.
Almost equivalent to business critical
Almost equivalent to business critical.
with the max number of cores engaged.
Yep. So in that use case, they stayed general purpose. They went next gen general purpose versus business critical because it was going to be a substantial increase in cost for them, but they got the IOPS they needed. And that's what the story was, right? So yeah, it's a great use case, a great way to see how you can easily troubleshoot your PaaS services, right? So what is the cost of Database Watcher? We touched on this briefly. Essentially, what's free is the watchers, the dashboards. There's no per instance data cost there for your per instance. We don't charge you for monitoring the services. We charge you for consuming the data from your Azure Data Explorer or from your Fabric capacity. And that's there. If you're kicking the tires, once again, and I've got links in the slide decks, use the free cluster. Don't be afraid to use that. I'm not a salesperson. I'm not going to tell you to spend money on Azure. My goal is to make your day in Azure a good one, because if you stay there, then you're going to bring more pieces to Azure. So our goal is in the factory team. I work for factory team. I didn't share that earlier, but anyhow, We help folks migrate to Azure. We're a free service out there. Reach out to me. I can put you in contact if you have Microsoft reps. We help folks migrate to Azure. Um, so that's the free versus paid. This is an important slide. We are looking for that feedback. Here's the email and the AKS SQL feedback link there. The slides are uploaded. If you're using Database Watcher or you saw stuff today that you're like, that doesn't hit the mark for what I'm looking for, send that feedback. Or, for example, one of the number one pieces of feedback we get, we need you to monitor an Azure SQL on VM, or we need you to monitor a VM on premises for us. We can't just monitor our PaaS services. We have more than that. Now is the time. Microsoft is listening and investing. Brad brought this up. We're talking with the PG group, not daily, but almost daily these days as things are progressing, and they're listening and they're heavily investing in what Database Watcher is or what it may become in the future.
Yeah, as a matter of fact, I would say some of the biggest feedback and questions that we typically get is that we'd like to be able to monitor SQL Server. To that, I would say, stay tuned. We'd like to be able to monitor SQL Server in a virtual machine. Stay tuned. We'd like to be able to monitor SQL Server in an Azure virtual machine. Stay tuned. We'd like the setup and configuration to be even easier. Stay tuned.
tuned.
Yeah. So this next year is going to have a lot of wonderful things that we will eventually be able to talk about. And maybe when we come here next year, we might do another performance tuning pre-con where we're using this service because it'll cover a lot of really amazing things. But if you can use this today, absolutely encourage you to use it. And as Dan was saying, absolutely look at that feedback. The team is open. They are listening and they have done a lot of planning. There's more planning they will do as the year goes along.
Follow our channel because I know for a fact, whatever Database Watcher becomes, the stay tuned, there's going to be videos up there for that. And the changes coming, folks, are extremely exciting. I can't emphasize
Well,
that enough.
and one thing I would add, so when you look at the Fabric configuration, you go, hey, how do I make those dashboards? Or if I make those dashboards, how do I make them easy? Every dashboard in the Database Watcher interface that you set up, there's a little 3 buttons on it. If you click on it, it will have the KQL code on there. You can take that code, you can store that, so that way you can create that in Microsoft Fabric. So it's not like you have to reinvent the wheel. You can literally take one KQL query and just put it in another place to be able to utilize it. And then that data activator is an alerting system. It's a very, very powerful alerting system in real-time intelligence where you could trigger another process. You could trigger a function. You could trigger a notebook. You could trigger a Teams message. You could trigger a pipeline. You could trigger all kinds of actions based off the alert that you do want to set. And if you're looking for, hey, we'd like some of those automatic alerts to be there for Fabric as well, stay tuned.
So while he was talking there, I just went through that step. It's that little paper plane AirBirdie thing. You click on it and it opens up the KQL that it's writing. One thing we didn't cover since we had just a couple of minutes left and I put up the session slide is within my Database Watcher. I cheat a lot, folks. Nobody claimed I was the smartest tool in the shed or sharpest tool in the shed.
Getting your working smarter, not
But
harder.
here are all the different here's the explain command if you want to explain something. Here's the questions that I was asking Copilot, and I was asking it, okay, which managed instance has not collected within the last 15 minutes? I didn't know how to query that probe inside the table. And so that query, I said, hey, I'll send you. Copilot created that for me and created that probe that gave me the information when something wasn't being alerted within 15 minutes. And that was through Copilot. And you can see I have a laundry list that I saved for y'all of the different prompts I put into there to be able to build these dashboards, to be able to build these alerts. I did it right there in Copilot in, 15, 20 minutes for some of these alerts with clients like that. So don't be afraid to use Copilot now that it's below F64. I run this at an F2 all the time. So don't be afraid to use it.
If anybody has any questions, let me know. I will
Paul,
over
that's
to you
the
with the
question.
microphone.
So I'm not going to stand in front of you though. So I'm going to back up. I have a question and a comment. Which one would you like first?
Comment first. Yeah.
Okay. The comment is, I really appreciate you taking the time to go through a demo, which I think showed me just about everything. that Database Watcher can offer. I appreciate the familiarity of what I just saw. It looks very similar to something else that's near and dear to my heart. And I appreciate that. And the terminology in there, the fact that you have signal weights right front of the center. Love all of that. You mentioned
Mm-hmm.
how earlier you were like, hey, here's the thing we all want to see in the performance tool. And my comment is, what I want to see in the performance tool is a list of actions I can take to make things better.
And
Okay. So, hey, this wasn't a question. This is a comment.
sorry. Oh, that was
Right?
a comment.
Right. Well, that's what we're really looking for. Because when you get at volume or scale or however you want to put it, trying to click through all of those tabs to diagnose a problem is not practical.
I agree 100%. So yes, I agree. So now that was the comment, Brad. Brad. So Tom still has the mic, folks. So we'll let Tom keep the mic. Go ahead, Tom.
So the answer is stay tuned.
Stay tuned.
No.
Stay tuned to dashboard.
Cool.
Because
Stay tuned.
all the thing that Tom said I can do and make actionable in a dashboard. But
in a data.
so
Now's my question.
circle around. Yep.
Out of
question.
everything that you had in there,
Yes, sir.
you have, again, a lot of information, but it's not a lot of context. And one important piece of context, like you talked about how, oh my God, it was storage, and that was the last thing you checked. And that's just pure dumb luck. It's not that you didn't know. It's just pure dumb luck. You were
Okay.
looking at all the right things. But what's missing from there, and is something you guys entirely have the ability to access because you control it all, is network. How did I not know that there was a network bottleneck that might have been? You could have gone to that storage tab and still seen nothing because you know nothing about the pipe, right? Right. So my question is, how soon can we expect you to think about giving us, metrics that go one layer deeper than just showing me CPU and things like that? I want to know things about, we've talked about this thing about feature engineering of taking these metrics and making them a little bit smarter. But if you're not going to expose and give us some of that network information, we're still going to have a blind spot.
And you're talking when you asked the
So-
question about looking for network information.
If I could do this real quick. I mean, you do have something if you want to show it.
No, I gave him the Rick and Morty face there, y'all. I love Rick and Morty.
Yeah.
I gave him the Morty face. No, go for it, brother.
Okay, so imagine if you would that we are in Azure and all that telemetry is stored, and we have all of that in Azure Monitor because we look at things at a higher level, and the product group has probably heard this feedback, to which I will say, stay tuned. I told you it's going to come over and over again as we go through the next year, and it's going to come much quicker than you realize. But by the time we get here 1 year from now, everything you think that you're asking for, you will have, and probably more.
We've got the Wizard of Oz. We've seen behind the curtains. We can't share because we're under NDA, right? And I love my job. I really love my job. There should be an easier way in a single pane and a single dashboard. And I will definitely take that feedback to the team. Get out of here.
Yeah, thank you for hanging out.
Still here, go.